every pixel in a Landsat image has a story associated with it. So we're talking millions and billions of stories that are possible. And that to me is an exciting part of where we are in this remote sensing time frame. Everybody can be part of this and they can tell their story. They can put themselves on this timeline and associate what's happening on the ground with these numbers and these pretty pictures from space.
Hello, everyone, and welcome to another episode of Eyes on Earth. Our podcast focuses on our ever-changing planet and on the people here at EROS and across the globe who use remote sensing to monitor and study the health of Earth. My name is Tom Adamson, your host for this episode. Our guest today is Peder Nelson, who is affiliated with the College of Earth, Ocean, Atmospheric Sciences at Oregon State University, located in the city of Corvallis, Oregon, in the western part of the United States. He is a senior instructor of geography and geospatial science, teaching both undergrad and graduate intro to geospatial or remote sensing classes. He is a senior faculty research assistant with Dr. Robert Kennedy's Environmental Monitoring, Analysis, and Process Recognition Lab. And he's currently leading several remote sensing-focused citizen science projects. So glad you could join us on Eyes on Earth, Peder.
I'm really excited to be here, Tom, to talk about one of my favorite subjects, which is Landsat and EROS.
Yeah, and as you know, the USGS EROS Center celebrates its 50th anniversary this year. What we're all about is the deep archive of Landsat and other land data. Now, how important is it that we have this historical archive, which we think of as a public good?
For me, it's how I've understood the world around me. It's through maps. I was one of those people that was given a map early in my life and told if I was sitting in the navigator seat, I needed to know how to read a map and know where we were going. So that was an early thing that I was taught. And the archive of USGS related topographic maps and aerial imagery are all things that I was using from a very early age. So I really just have come to understand, why things look the way they do, partly is mapped for me. And that's a really wonderful tool where I can imagine places and then actually go to a lot of them.
You also have a personal connection to EROS, don't you?
I do. And this is one of those things that pardon me for kind of going down a little bit of memory lane here, but I am excited about this personal connection that I've been exploring, which is my dad. And he worked at the EROS Data Center early on, about 1974 to about 1984. And then he came back later in his career. And so a lot of my early memories of life are going out to the EROS Data Center. My mom played on the softball team. And so we would go out there and have picnics. And I would run around as a little kid around that place that was getting these satellite images. And I was just a little kid having fun playing around EROS.
And it's in a rural location, so there was plenty of room.
There was, exactly. That was something that I learned to appreciate when I started traveling other places. I had no idea why EROS was in the place that it was, but that flatness really plays a crucial part in why it is located where it is. And for me, why I was born where I was. And so my life is definitely intertwined with EROS and this unique place that it ended up.
In some of your presentations, you have used the term generational science. Can you tell us more about what you mean by that?
When we think about our responsibility in this moment of time living on Earth, we have a responsibility to the generation in front of us to tell the stories of how we got here today so that they can understand what planting that tree really will do, and they can use it as something that might help them in the future. And they can know how to use the power of something like Landsat to look across time, to look across generations, and to look at themselves in the whole of the planet.
The mere existence of all of this data sure is a great thing, but you said something in a recent presentation. I'll quote you now. Pixels don't have much information until humans come along and reveal the patterns, the reasons for these changes. So that sounds like the important work of remote sensing scientists.
You're right. And this is a really fun pivot that's happening in remote sensing right now. We spent the last 50 years trying to understand the numbers. What happens in this particular landscape and what are the numbers that we're measuring, using this particular sensor, the Landsat sensor. And how do we actually integrate that across time and bring in new bands, new spatial scales, new capabilities, new orbits? We've spent a lot of time focusing on that. We now can understand the numbers. We can run a lot of analysis doing math and put those places on Earth. When we're trying to understand those pixels and the colors and what we see from these sensors, we have to start turning to the elders in our community. They have the stories that are not put into this digital space. And they're the ones that can tell us why they made some of the decisions that they did, or what was happening around that area while they lived in that location. So trying to understand the past isn't just about the numbers and isn't just about the spectral values that we get from a sensor like Landsat. It really is trying to understand why those numbers are happening in the way that they are. And at a fundamental level, trying to separate out what are people responsible for and what are they doing, building things, maybe clearing out trees, growing crops, living, all of those kinds of things, versus what are the natural cycles, natural processes, and that are out there that might be impacted by some of the things that we're doing. And by that, I mean things like our water quality or things like droughts and how humans are reacting to that and how cities are reacting to that. All of that is in the Landsat archive. And so understanding the 1980s era of the Landsat archive is about going back and talking to my elders while I still can, while they still have the stories, while I can still record it and get it associated with that location. So that as these numbers, as the spectral measurements keep coming down from space, we can understand that historical perspective of why we are seeing the reds, the blues, the browns, and those spectral numbers that we're actually getting from space and from our ground perspective.
People at EROS often talk about the satellite imagery isn't just pretty pictures, it's scientific measurements.
It is scientific measurements. And that was something I didn't quite appreciate when I was younger. And the way that it is portrayed is it's just an image. A lot of the digital imaging that people are doing with their mobile devices is remote sensing. And one of the key differences between what we do on our mobile device when we take a photo of the ground is that it's calibrated, right? We understand the sensor itself. Now, all of us have a remote sensing tool in our pocket if we were to calibrate it or if we were to understand it and describe it, right? And so this new age that we're living in of everybody being able to be a remote sensor, a digital remote sensor, is a new time that allows us to invite the public into what people have been doing at EROS for 50 years. And to me, that is the exciting piece that, when I was running around on the softball fields as a young kid, people would ask me, the typical question that they ask a kindergartner: what does your dad do? Well, my answer to that was he made maps. It wasn't until I started working with those numbers and understanding that those numbers actually have meaning. A certain vegetation index value actually means some greenness on the ground. How do we turn those into actionable data, into decision-making data that can improve our life on Earth? If we look at the past and understand the impacts of decisions, and we can look at the Landsat archive and see what the impacts of many decisions were in the past. Did we get the trees growing in those places that we actually planted them? If not, why? Let's learn from that. That's where the Landsat archive really opens up brand new questions that nobody else has really been able to investigate. Every pixel in a Landsat image has a story associated with it. So we're talking millions and billions of stories that are possible. And that to me is an exciting part of where we are in this remote sensing time frame. Everybody can be part of this and they can tell their story. They can put themselves on this timeline and associate what's happening on the ground with these numbers and these pretty pictures from space, because the future generations are going to be able to do things and make use out of that and also judge us by our decisions, because it is embedded in this mapping, measuring, and monitoring activity that is foundational to Landsat.
Hey, I should point out that the softball field at EROS is not there anymore.
We've had a land cover change there, Tom.
We did. It's now a parking lot, and I'm not sure you can appreciate that when you're looking at that now parking lot from Landsat. You might need a ground photo to be able to identify that particular change.
My parents took a lot of photographs, of them playing softball, of various picnic activities, of the early staff at EROS. These ground photos at the time, my parents weren't intending for me to focus on that tree that's behind them. They were just taking a picture of the team, the softball team. But now, like you said, Tom, now we can actually look at that and understand, the carbon that was lost by putting a pavement in, a parking lot. And so putting myself on that timeline and being able to use those old family photos in a way to understand what it looks like today is pretty exciting to me.
There are a multitude of these citizen science projects that a lot of different people are doing. I know there's one in particular called Globe Observer that you're a part of.
Yeah. So the Globe Observer is a mobile app, and it is part of the larger Global Learning and Observations to Benefit the Environment program. It's one of those things that I was drawn to because of the connection between education and remote sensing. I wanted to invite everybody, the lifelong learners, everybody who is now walking around with that sensor in their pocket. I wanted to invite them into putting themselves on this Landsat time series, because finding data and finding stories is really challenging. It was this science need that led me to citizen science and trying to find ways of building frameworks or structures to have people help the scientists understand the world around them, and not just do it for a short 3-year time frame, but on the same time frame that the Landsat archive is operating on, so that we don't end up looking back and saying, I wish that I knew what was happening there before this event occurred. And that's what I've learned, is we can never have enough information. And so Globe Observer in the mobile app is one way that we have provided a mechanism for everybody to participate on the Landsat timeline and to be part of the remote sensing science. And all it is following a protocol. I found that that's an intimidating word for some people, but it's just following instructions. Yeah. Right? It's not that intimidating. And so our instructions is we want to sample what the sunlight is doing at a location. And to do that, we have people take photos using their mobile device. And in the north, east, south, west directions, as well as a photo of the sky, and then also a picture of the ground, so that we can see what that looks like in that location. So we're kind of asking you to be like a satellite with the citizen science activities, because that can then be put into a database and shared in a classroom for science activities, or with professional scientists, or for students and decision makers 20 years from now. And so my goal with citizen science on the ground here of Earth is to connect it to what we're learning and what we're seeing from space, in particular, this Landsat archive. I want other people to see the value of something simple like taking digital images can be valuable for scientists. Science doesn't have to be complicated, does it, Tom? These systems were happening whether I was paying attention or not. It didn't require me to actually be part of what was happening at the very beginning of the Landsat program. So when we talk about generational science and what EROS and what we're celebrating the last several years with the 50th anniversary of Landsat, the 50th anniversary of EROS, we're talking about building systems that help all of us, whether we're paying attention or not. And to me, that is something that is really special. It's something to be celebrated because it didn't happen by accident. There were people who were building this for us today. And this conversation and what you and I are doing is setting the stage for what the next generation and the generation after them will be able to do.
How is it that you stay so excited about this stuff?
It's something that very few other people have been able to do ever. Use the sunlight to understand how much photosynthesis is happening. Wow. 100 years ago, nobody was doing that. It wasn't possible. The superpower that we have today through tools like Landsat, through tools like our mobile devices and sensors that allow us to experience the world more in depth in a way that can help us to understand the world around us. I find this ability to use remote sensing in this way, to capture it in this way, and then to be able to actually talk about it with other people through the numbers. It's astounding that other people were smart enough to create the system that I can just marvel in and sit within. But that also makes me realize that I have a responsibility to keep it going. So I would say that's what keeps me going and motivates me, because everywhere I go, if I stop and pay attention to that sunlight, where it is in the sky at that moment, every moment is different. And so it's always changing, and it always brings fascination to me as a human here on Earth at this moment, trying to understand why things look the way that they do. And I think of Virginia Norwood and her team that came up with a way of repeating this measurement. And that was the key that we're living in right now, is this repeatability of this measurement. That's what makes it science, is that it's repeatable and people can participate in a lot of different ways. And I'll just say, then it's on to scientists to then make good use of all of this information that citizen scientists are volunteering with their time, their energy, and literally their computing. Moving into this science for all, benefit for all approach to science, it to me is where we're going with not only Landsat, but remote sensing, but also the larger science endeavor that I'm just really excited to be part of, to having found myself fortunate enough to be put on this timeline and be able to contribute in my small way, including having a conversation like this.
Thank you, Peter, for joining us on this episode of Eyes on Earth. There are certainly a lot of ways everyone can put themselves on the Landsat timeline. And thank you, listeners. Check out our EROS Facebook and Twitter pages to watch for our newest episodes, and you can subscribe to us on Apple Podcasts.
This podcast
is a product of the U.S. Geological Survey, Department of Interior.